In the endless, silent darkness beyond our skies, a new kind of vision has opened, and it's seeing things we were never prepared to find. The James Webb Space Telescope, the most advanced instrument we've ever built to peer into the deep cosmos, is not just capturing breathtaking views of stars and galaxies. It's finding anomalies, patterns, clues, and maybe even warnings. These are not just scientific curiosities. They are cracks in the surface of what we thought we knew, hints that the universe may be far more complex, reactive, and perhaps even aware than we ever dared imagine. A chill on Neptune. It started closer to home. When Webb turned its infrared gaze toward Neptune, a distant gas giant on the edge of our solar system, it saw something strange. A dramatic cooling in the planet's upper atmosphere, nearly 10 degrees Celsius colder than what earlier observations had shown. A sudden, unexplained drop. No change in solar radiation. No known planetary event. And with it, subtle shifts in Neptune's magnetic field, something shifting, pulling, or pressing against the planet from afar. Is it a gravitational disturbance? A passing field of dark matter? Or something stranger, something distant, yet deliberate? TRAPPIST-1. Not just habitable, but alive? Further out, in the TRAPPIST-1 system, a miniature solar system just 39 light-years away, Webb uncovered something even more extraordinary. TRAPPIST-1 is known to host 7 rocky planets, 3 in the so-called habitable zone. But what Webb detected wasn't just temperature data or planetary outlines, it was signatures of water vapor, thick atmospheres, and perhaps most haunting of all, chemical traces similar to Earth's ozone layer. 2 planets, TRAPPIST-1d and 1e, showed signs of global oceans and complex chemistry. Conditions not just for life, but for long-standing, stable biospheres. This isn't proof of life, not yet. But it's the closest we've ever come. 1 habitable world was a dream. 2 in 1 system? That's a message. The early universe, woken too soon? Peering even deeper into ancient space, Webb captured light from Jade GSZ 130, a galaxy formed just 330 million years after the Big Bang. It should have been shrouded in hydrogen fog, invisible, silent. But the light from Jade broke through, strong and clear. A frequency of radiation, Lyman alpha emissions, that shouldn't have been possible at that time. This challenges our entire understanding of cosmic dawn. Something accelerated the universe's transition from darkness to light. Not slowly, but violently. Abruptly. A natural anomaly? Or was something there, something massive, powerful, or deliberate, that ignited light long before it was expected? A planet that survived death and the glowing remnants of a dead star, scientists expected ruin. But in the WD 1856 plus 534 system, Webb found something that shouldn't exist. A massive planet orbiting just a few million kilometers from a white dwarf star. A world that should have been vaporized, yet wasn't. Not only had it survived, it had adapted. Its atmosphere showed signs of chemical recycling, with traces of water vapor and sulfur compounds, like the planet was healing itself. Could life exist in such places, not in light but in darkness? Could civilizations evolve not just around suns, but after them? The frozen moons that shouldn't be alive. Turning back toward our solar system, Webb examined the forgotten moons of Uranus and Neptune, icy rocks long thought to be dormant. But what it found was heat. Infrared scans revealed warmth on tiny moons like Hippocamp and Despina, far too warm for their size or distance. Some even had organic carbon signatures on their surfaces. Internal heat without sunlight? Complex molecules where there should be none. Theories range from radioactive decay to tidal heating, but the organization and consistency of these findings suggest something else. Maybe these moons weren't formed here. Maybe they were seeded. The pulse from Messier 82. Messier 82, the cigar galaxy, has long been classified as a starburst galaxy, teeming with violent starbirths and supernovae. But Webb's instruments found something else. A repeating infrared pulse coming from its core. Not random noise. Not static. But a pattern, regular, rhythmic, mathematically structured. It echoed the types of signals we once hoped to detect in the SETI project, structured enough to suggest intent, but buried deep in cosmic chaos. Was it once a signal? Is it still one? Or are we witnessing the decay of something ancient, something no longer broadcasting to us, but leaving a fading echo behind? Tabby's star. The mystery deepens. Tabby's star, known for its erratic, unexplained dimming, became a viral sensation years ago. Some suggested alien megastructures. Most dismissed it as dust or comets. But Webb took a closer look. And what it saw didn't debunk the mystery. It deepened it. Geometric shadows passed over the star, thin, opaque, angular, not natural clouds or rains. Some moved in swarms. Others blocked light in perfect intervals. And nearby? A steady thermal signature. Not from the star. From something around it. Something harvesting energy, leaving behind only the waste heat. Scientists are now cautiously reviving a theory once reserved for science fiction. A Dyson swarm, not as fantasy, but as a working model. Invisible shadows in the Pandora cluster. Finally, in the Pandora cluster, one of the most distant and chaotic galactic fields ever observed, Webb saw something it wasn't supposed to. Shadows. Moving across background galaxies. Not once, but repeatedly and with precision. Objects large enough to block light, yet completely invisible in every other spectrum. No glow. No reflection. Only absence. Some now believe these may be non-reflective megastructures, possibly even cloaked objects, using advanced physics to stay hidden, only giving themselves away by what they block. Not missing matter. Not dark energy. Something built to avoid detection. So, what is the James Webb Telescope really seeing? This isn't just about pretty pictures. It's about patterns. About finding structure in places we thought were random. From strange heat on frozen moons to artificial pulses from galaxies, from possible oceans on distant Earth-like planets to light signals escaping from a universe that wasn't supposed to be awake yet, Webb has pulled back a curtain. And what lies behind it isn't just stars, or nebulae, or galaxies. It's questions. Why are we seeing these things now? What intelligence, if any, shaped what we're now observing? And are we the first to look back, or just the first to notice? Final thought. A watchful universe. We once believed the universe was indifferent. Cold. Vast. Empty. But what if it isn't? What if the void watches? What if the stars don't just shine, but listen? And what if, in pointing our most powerful eye toward the edge of existence, we've not only seen the truth, but been seen in return? If this shifted your view of the universe, even just a little, don't let it end here. Subscribe for more revelations. Flying saucer, comment with your thoughts. Is the universe alive, or inhabited? Rocket, share this with someone who's ready to ask the hard questions. Because James Webb is just getting started. And the deeper it looks, the stranger things get.